Hello student friends, today is the important lecture on the expression for capacitance of parallel plate capacitor. Consider a parallel plate capacitor. One of the plate is charged with positive and other is charged with negative. Let sigma be the surface charge density on positive charge plate and minus sigma is the surface charge density on the negative charged plate, and A be the area of each plate. A be the area of each plate, and small d is the separation or the distance between two plates, and Q is charge on each plate. A parallel plate capacitor consists of long plates. Parallel plate capacitor consists of two long parallel plates, and here we assume that these parallel plates behave as uniformly charged plane surface, and for uniformly charged plane surface, electric field is given by E equal to sigma upon 2 epsilon naught. This we have derived in first topic, that is electric field due to uniformly charged plane sheet, and is given by sigma upon 2 epsilon naught. And electric field outside the plate, two plates, is equal to 0. Here electric field outside these plates are subtracted, that is sigma upon 2 epsilon naught minus sigma upon 2 epsilon naught is equal to 0. Hence electric field outside the plates is equal to 0, and there exists only electric field inside the plates of capacitor, and electric field is always directed from positive charge to negative charge. This is the direction of electric field from positive charge plate to negative charge. This is the direction of electric field, and the direction of electric field due to negative charge, it is towards the negative charge. Electric field due to positive charge is away from the charge, and electric field due to negative charge is towards the negative charge. Hence here fields due to positive plate and fields due to negative plate, they add up. Hence the total electric field due to two long parallel plates is equal to sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught. Let E1 be the electric field due to positive charge, E2 be the electric field due to negative charge plate. Hence E equal to total electric field, E equal to E1 plus E2. Here E1 equal to sigma upon 2 epsilon naught plus E2 equal to sigma upon 2 epsilon naught, and that is equal to sigma upon epsilon naught. That is 2 sigma upon 2 epsilon naught is equal to sigma upon epsilon naught. But we know that sigma equal to Q upon A. Therefore, E equal to sigma equal to Q upon A. Q upon A into epsilon naught. That is Q upon A epsilon naught. It is the electric field at any point between these plates is Q upon A epsilon naught. And the potential difference between the plates is given by potential difference V is equal to E into D. E into D. Because we know that electric field is equal to potential gradient. And we have derived the relation between electric field and potential difference as E equal to dV by dr. Here dV is the potential difference, dr is the distance between two plates. Therefore, electric field can also be written as, consider this as equation 1, E equal to Q upon A epsilon naught, and also E equal to phi upon D, where phi is the potential difference between the plates and D is the distance between the plates. This implies potential difference phi equal to E into D. And according to definition of capacitance of a capacitor, C equal to Q upon P. In previous class, we have discussed capacitance of a capacitor is the ratio of charge on the conductors or plates of a capacitor to the potential difference between them. C equal to Q upon P. Here Q is charge on each plate of the capacitor and phi is the potential difference, and phi equal to E into D. And also we know that E equal to Q upon A epsilon naught. Therefore, potential difference phi equal to Q into D upon A epsilon naught. Hence, and if the space between two plates of a capacitor is filled with air or vacuum, then capacitance of a capacitor with air or vacuum is denoted by C naught. C naught is the capacitance of a capacitor with air or vacuum in between the plates. Thus, C naught is equal to Q upon potential difference QD upon A epsilon naught. Here Q get cancelled. Therefore, C naught, that is the capacitance of capacitor, parallel plate capacitor with air medium, is A epsilon naught upon D. A epsilon naught upon D. This is the capacitance of parallel plate capacitor with air medium between the plates is C naught equal to A epsilon naught divided by D. And if the space between the parallel plates is completely filled with a dielectric medium of permittivity epsilon naught, permittivity epsilon naught is the permittivity of free space or air medium, and epsilon is the permittivity of dielectric medium, then here potential electric field is given by E equal to Q upon A epsilon naught, and potential difference is given by phi equal to QD upon A epsilon. If the distance between two plates is completely filled with dielectric medium. This is for air or vacuum, and for dielectric medium with permittivity epsilon. Epsilon is the permittivity of dielectric medium. Potential difference phi is equal to epsilon naught is replaced by epsilon, that is phi equal to E into D. Here E equal to Q upon A epsilon naught. E equal to Q upon A epsilon. Here epsilon is the permittivity of dielectric medium, and this is QD upon A epsilon naught. It is the potential difference between the plates of capacitor when the space between them is filled with a dielectric medium with permittivity epsilon. Then potential difference phi equal to QD upon A epsilon. Now if C is the capacitance of a capacitor with the dielectric medium, then C equal to Q upon phi. Q upon phi is the expression for capacitance of capacitor. It is the general expression for capacitance of capacitor. Hence, capacitance of a capacitor with dielectric medium is equal to Q upon phi, where phi equal to QD upon A epsilon. QD upon A epsilon, that is equal to, here QQ get cancelled, therefore remaining capacitance of a capacitor with a dielectric medium is C equal to A epsilon upon D. A epsilon upon D, or C equal to A K epsilon naught upon D. This is the expression for capacitance of parallel plate capacitor if the space between the plates is filled with a dielectric medium of permittivity epsilon and dielectric constant K. Here epsilon is replaced by K into epsilon naught, because we know that dielectric constant, it is the ratio of permittivity of dielectric medium to the permittivity of free space. In first chapter we have explained it as K is the dielectric constant or permittivity of free space, relative permittivity, and dielectric constant or relative permittivity is K equal to epsilon upon epsilon naught. Hence epsilon equal to K epsilon naught. Hence C equal to A K epsilon naught upon D. Clear? Therefore, capacitance of capacitor, parallel plate capacitor, increases by using a dielectric medium. The capacitance of capacitor is with air medium is C naught equal to A upon epsilon naught into D, and capacitance of capacitor with a dielectric medium is C equal to A K epsilon naught upon D or A epsilon upon D. And now we discuss the dependence of capacitance of capacitor. Capacitance of dependence of capacitance of a parallel plate capacitor or any capacitor. We know that capacitance of a capacitor is given by C equal to Q upon P. This is the general expression for capacitance of a capacitor, where Q is charge on the plates of a capacitor or conductors of a capacitor, and V is the potential difference between them. And capacitance of parallel plate capacitor is given by, with air medium, is given by C naught is equal to A epsilon naught upon D. And capacitance of capacitor, parallel plate capacitor with dielectric medium is given by C equal to K A or A K epsilon naught upon D. Here capacitance of capacitor with air medium is less than the capacitance of capacitor with a dielectric medium. Here A epsilon naught upon D, and it is A into K into epsilon naught upon D. That means capacitance of a capacitor depends on dielectric constant of the medium or permittivity of the medium, or this can also be written as A epsilon upon D. Here from C equal to Q upon V, capacitance of a capacitor does not depend on Q or V, charge on the capacitor and potential difference between the plates of the capacitor, because as charge increases, potential difference also increases proportionally. Hence, capacitance of a capacitor remains the same. Therefore, capacitance of capacitor does not depend on either charge or potential difference between the plates of capacitor. Now, From this, C naught equal to A epsilon naught upon D. Here, capacitance of capacitor with air medium is directly proportional to area of the plates and is directly proportional to permittivity of the medium. For air or vacuum, permittivity is epsilon naught and inversely proportional to distance between the plates. Inversely proportional to distance between the plates. Therefore, capacitance of capacitor increases with area of the plate. As area increases, capacitance increases and is directly proportional to permittivity of the medium. As permittivity of the medium increases, capacitance increases and the distance decreases, capacitance increases, because the distance between two plates is inversely proportional to capacitance, or capacitance is inversely proportional to distance between the plates. Therefore, the factors on which capacitance of a capacitor depends are: number one, it depends on capacitance depends on area of plates or conductors. Area of plates of capacitor. Capacitance, the factors on which capacitance of a capacitor depends are: capacitance depends on area of plates of a capacitor. It depends on permittivity of medium. Permittivity of medium between the plates, and it depends on the distance between the plates. Distance between the plates. As area decreases, capacitance decreases. As permittivity decreases, capacitance decreases. As distance decreases, capacitance increases. Clear? Then, what are the methods used to increase the capacitance of a capacitor? Methods of increasing capacitance. From this relation, as area increases, capacitance increases. Therefore, number one, by increasing area, by increasing area of the plates, capacitance of a capacitor can be increased by using a medium of higher dielectric constant. Higher dielectric constant. That means as K increases, capacitance increases, and by decreasing distance, by decreasing distance between the plates, In this session, for 5 marks, derive an expression for capacitance of parallel plate capacitor with air or vacuum, or derive an expression for capacitance of parallel plate capacitor with a dielectric medium. Therefore, you have to extend capacitance of parallel plate capacitor with air medium to dielectric medium, and that is C equal to A epsilon upon D or A K epsilon naught upon D. Next, what are the factors? Next question for 2 marks. Mention the factors on which capacitance of a capacitor depends. Capacitance of a capacitor depends on area of plates of the capacitor. It depends on permittivity of medium between the plates, and it depends on the distance between the plates. Next question for 2 marks. Mention the methods of increasing capacitance of a capacitor. Capacitance of a capacitor can be increased by increasing area of plates of capacitor. It can be increased by using a medium of higher dielectric constant. Number 3, by decreasing the separation between the plates, or by decreasing the distance between the plates. Clear? Extra information. Capacitance of spherical capacitor. A spherical capacitor consists of 2 spherical conductors separated by a small distance. Let A be the outer radius of inner sphere and B is the inner radius of outer sphere. Then, and if the space between 2 conductors or 2 plates is filled with air or it is vacuum, then capacitance of spherical capacitor is given by C equal to 4 pi epsilon naught into AB upon B minus A, where A is outer radius of inner sphere and B is inner radius of outer sphere. And if the space between 2 plates or 2 conductors is filled with a dielectric medium of permittivity epsilon, then it can be written as C equal to 4 pi epsilon into AB upon B minus A, or it can be replaced by K epsilon naught. Next, capacitance of cylindrical capacitor. A cylindrical capacitor consists of 2 cylinders of radius A and radius B, and they are separated by a small distance. If A is the outer radius of inner cylinder and B is inner radius of outer cylinder, and if the space between 2 cylinders is air or vacuum, then capacitance of cylindrical capacitor is C equal to 2 pi epsilon naught upon 2.303 into log of B by A, where B is inner radius of outer sphere, A is inner radius of outer cylinder, and A is outer radius of inner cylinder. And if the space between 2 cylinders is filled with a medium of permittivity epsilon, then it can be written as 2 pi epsilon upon 2.303 into log of B by A. and this is extra information for CET, NEET and JEE. And in next class we shall derive an expression for energy stored in a capacitor. And goodbye, study well. Thank you.